Right, when you take a look at this circuit, it's really important to recognize that this is a series circuit. A series circuit is going to have all of the resistors sort of lined up along one loop, and that's going to allow us to very easily find the equivalent resistance. Recall that when you have a series circuit, that the current is the same everywhere, but the voltage values all add up. As you look at each of the resistors, it adds up, in this case, to 12 volts. So we're going to use all that information to either calculate or to check our work. First thing you always want to do with a series circuit, if you have enough info, is find that equivalent resistance. And for resistors in series, you just add them up. So however many resistors you have, you just keep adding them up. So in this case, we would take our 20 ohms plus 30 ohms, and we have 50. And why that's so important is because that's what the battery sees. And so you need to know that load that is on the whole circuit so that you can find the current through the battery. So the current of the battery is going to be the voltage of the battery divided by what the battery sees, which is what we call the equivalent resistance. So that's going to be 12 volts divided by 50 ohms, and that's our 0.24 amps, coulombs per second. Okay. Now, why that is so important, again, is because once you find that number, that kind of opens up the whole problem, because that is the same value everywhere in the circuit. So now I can keep on reusing that number. So for instance, if I want to look at this 20 ohm resistor and I want to know how much voltage is across it, what's the voltage drop across that resistor, I can use V equals IR for that particular resistor. And it looks like I'm using the current that I just calculated for the whole resistor, for the whole circuit, but again, in reality, it's because it stays the same everywhere. So it's really the current through the 20 ohm resistor that I'm thinking. And that comes out to be 4.8. And then if I switch and I take a look at the other resistor, the 30 ohm resistor, then it's still doing V equals I times R. Same current, same all the way through the whole circuit. And in this case, that's going to come out, that's really sloppy, that's my ohm symbol. Let's fix that up here. Okay, that's going to come out to be 7.2 volts. Now that may not seem exciting to you, but the fact that the 4.8 plus the 7.2 equals 12 lets me know that I have checked my work and it is correct, because the voltages should add up. So I am very confident that I have done this question correctly. Now, we don't always have enough information to find that equivalent resistance right away. In this case, I don't know what this unknown resistor is up here, so I can't, add R plus 50 or some number plus 50 and find my equivalent resistance. But because I know so much information about this other resistor, I know its value of R and I know the voltage across it, I'm going to be able to figure out my current a different way. So this time I'm going to start by looking just at the 50 ohm resistor. So just kind of focusing in on that one part of the circuit. And I can say that the current through that resistor would be the voltage across it divided by R. So notice I'm not going to use this 40 volts because that's the voltage for the whole circuit. I'm just going to use this 10 volts because that focuses just on that single resistor. I'm going to put those two pieces together. My current then through that particular resistor would be the voltage across it divided by its resistance. That comes out to be 0.2 amps. But again, what's great about series circuits is that current that we just found is the same everywhere. So whether I look at the whole circuit first and then look at a piece, or I know enough about a piece and now I can look at the whole circuit, either way it works. So for instance, now I can say V equals IR for the whole circuit, and I can say there's 40 volts across the whole circuit. And I know that there's a current of 0.2 around the whole circuit. And my R for the whole circuit, this would be the equivalent R when I'm using the battery voltage, okay? The equivalent R is all the R's added up. So it's some unknown value plus 50. So then I can do some math. I can divide both sides of the equation by this 0.2, and I can find out that that ends up being 200 equals R plus 50. And then I can subtract 50 from both sides, and I find my unknown resistance.